This video is going to talk about general area and volume of three-dimensional figures. A couple things to help you here. You need to make sure you're pausing to draw pictures. And the best way to draw a 3D picture is to just mirror the top and bottom of the object and connect it. That's kind of rough right there. But so if you're drawing, figure out what the base is, and then you can connect the figures. Okay. All right, so we're going to solve problems with area and surface area, and then 3D, solids, and then a few angles. We'll do more angles in class. So your formulas that are on your formula sheet, there's something called prior learning that is stuff that you've done in other classes, has a lot of the basic formulas, and then there's a few more of the complex formulas over here. You'll notice it's right along with the other trig stuff that we're doing, kind of goes along with the geometry. Important terms: radius is the distance from the center of a circle to the outside. Height, always be vertical. The key is on the height is that you know what the base is. Slant height is just how it sounds. So if you have a cone, this is the slant height, often called L. The same thing with the pyramid, depending on what the base of your pyramid is. But the slant height is this outside height. Surface area, if you were going to paint something, it's the outside. Pay attention to whether you're painting the top or bottom, or whether you're open or closed. So that does change the value. And then volume is if you were going to fill something up. That doesn't change whether it's open or closed. Okay, so we're going to do some basic ones. These are kind of from the prior learning. Given a sphere with radius 10. So we have a sphere. The best way to draw a sphere is to make a circle and then make this little ellipse in the inside. So the volume formula, 4/3 pi r cubed. So in this case, 4/3 times pi times 10 cubed, 4,190. Surface area is basically 4 circles, 4 pi r squared. So one of the circles is 100 pi. There's 4 of them. That's 400 pi or 1,260. Whatever your units are, they're squared. Distance around the square, one circle around the square, that is the circumference. And that's 2 pi r or pi d. So again, just looking them up and finding those values. Pretty straightforward with a sphere. Cylinder, can, if you want to think about a cylinder. So again, when you're sketching it, make the top, make the bottom, connect the sides. So we have a height and a radius. Pi r squared h is the volume. That's basically the area of the bottom. That's a circle, pi r squared, times the height. Any 3D shape, to find the volume, you take the area of the base times the height. So this 1,570 surface area, if it's open at both ends, we're using 2 pi r h for the area around the outside. So 2 times pi times radius times height. If you open this circle, if you open this cylinder up, it makes a rectangle. And one dimension is the height. The other dimension is the circumference of the circle. That's where the formula comes from. So it's 2 pi r by h. And if it's open at one end, you're going to add one circle. So we still have our 2 pi r h plus one circle. And if it's a closed circle or a closed cylinder, you're adding 2 circles. So you have to customize your formula for what it's asking. A couple things to note here, noting the names of the different shapes. Some people get confused. says which of these have the same form for volume. They actually all have the same formula, the area of the base times the height, but knowing what the shapes are, you can use special formulas. So this is a cylinder. It's 1/3 the area of the base times the height. Well, the base is a circle, so pi r squared. Anything with triangular faces is a pyramid, also 1/3 the area of the base times the height, only the base is a different shape each time. So like right here, it's a rectangle, here it's a triangle, pentagon, then we get more sides. So when you're finding that volume, you need to know what the base is. Do not confuse pyramids with a shape like this that has triangle bases. Okay, that's a prism or a cuboid. So we have a square pyramid. It means the base is a square. The volume is going to be 1/3 the area of the base times the height. So the base is 32 by 32, the height's 30. The slant height is 34. So that would be the height that goes down the middle of the side. It's at a right angle to the base. Don't confuse that with the edge. This is the edge. The slant height goes right down the middle. And the reason we need to know that is when we're finding the total surface area, we can add up all the triangles, and that slant height is important for that to find the area of that triangle. So we have, in this case of this shape, we have 4 different triangles plus the base. So we have a triangle around the outside. Each of these in this case is the same. So 1/2 base times height, 1/2 32 times 34. There's 4 of them plus the square base. And then the angle that the base makes with the base, you can see that theta popped in right there. So that's the opposite side. That's the slant height, which is the hypotenuse. That's why we're using sine. So they may ask for different angles here. They could ask for the angle that an edge makes with the base. If that would be the case, you'd have this triangle right here. Information given. Again, make sure you're pausing to make this drawing. So cuboid, it's the name of a rectangular prism. We would call it a rectangular prism. Everybody else calls it a cuboid. It's not a cube. It can be. So volume, length times width times height. The surface area is adding up all the faces. So what the easiest way to do it is to find, this 6 times 5, there's 2 of those. There's 10 times 5, there's 2 of those. And then the top and bottom, or the back and front, are 10 times 6, there's 2 of those. If you trace around it when you're making it, makes it a lot easier. Again, make sure you're pausing this video to get these drawings. And then an open box, the only difference between an open box and a closed box is we're not including one of these rectangles. Again, we're talking about surface area. Surface area changes, depends on when it's open or closed. Volume does not. A cone. To make a cone, you make an ellipse and then make a point at the top and connect. The volume, 1/3 pi r squared h. If you remember, a cylinder was pi r squared h. A cylinder and a cone that have the same height and the same radius, 3 cones fits into one cylinder? The slant height, sometimes called L, you can find using Pythagorean theorem. That'd be 11.2. And then the surface area formula is pi RL. So you are using that L with the surface area because it makes kind of a funky shape when you unroll it. Okay, so those are the basic ones. Those are review from prior learning. Add that circle in for the base. Okay, so what does it look like in a IB question? And we have some of the newer questions. This is an older question, but the topics haven't changed. Okay, so again, right now would be a great time to pause your video and see what you know how to do. Okay, so to find the area of the base of the cylinder is a circle. This was a question that threw people off. The picture that's here is not what the question up here is talking about, because that's a cone. Okay, so we have a cylinder with a radius of 4 and a height of 8. So the area of the base is just asking for that circle there on the bottom. So that'd be pi r squared. So pi times 4 squared. And I'm not going to multiply that out for you. I'm just going to leave it like that. Show that the volume is 402. This is a common IB question. They're telling you the answer. You have to show how we get there. So you go, okay, well, what's the volume of a cylinder? Volume of a cylinder is pi r squared h. So we need to show that we get 402. So pi times 16 times 8. And that one I would punch in my calculator because I need to show that I get that amount. So 8 times 16 times pi is 402.123, which is 402. That way we've verified, we've shown that. The reason they do that is to see if you know what you're talking about, and also later on in the problem, if you didn't get this one right, you can still use that answer. Find the total surface area of the cylinder. Well, we found the base, which is 16 pi. So there's 2 of those. And then we need to add to that the lateral area. And the lateral area of a cylinder is 2 pi RH. So a circle times the height. So 2 times pi times r, or circumference, sorry, not circle, times 8. So that's 8, that's 64 pi. So if I were adding those together, it'd be 32 pi plus 64 pi. So 96 pi. You can leave it like that or do 3 sig figs. So it kind of builds from simple to complex. I'll clear this off. So then we keep going, and it says the cylinder was melted and recast in a cone shown in the following diagram. So if you remember from the other problem, the volume was 402. So when you melt down metal and you recast it, you still have the same volume. But this time we have different information. We have a height of a cone. We have the radius of our cone. So we know the volume is 402, and the volume of a cone is 1/3 pi r squared h. So we're supposed to find h, the height of the cone. Well, we can do that by substituting what we know. We know that the radius is 6, so we have 1/3 pi times 36h. So if you take your 402 times 3 to get rid of the 1/3, and then divide by 36, and then divide by pi, and that will give you the height. Or just solve that equation however you want to solve it. It says find the size of angle BCO. So no matter what you get for the height, if you can't get something, just make something up. We got an answer, so we're going to go with it. It says find angle BCO. So there's my angle. It's even marked on there. So the way to find that angle is to see, we have a right triangle here. We have the opposite and we have the adjacent. So opposite and adjacent is tangent. So the tangent of our angle is 6 over 10.7. So to solve that, I'm going to do second tan 6 divided by 10.7, which is 29.3. Find the slant height, CB. We have a nice little right triangle, so 6 squared plus 10.7 squared equals C squared. Don't forget to take the square root. You get 12.26, so 12.3. And then it says find the total surface area of the cone. So the bottom of the cone is pi r squared, and the side of the cone is pi rl. So r is 6, so we have 36 pi plus 6 pi, and we just found L, which was 12.3. So you'd be adding those together. So the problem kind of builds. Anytime you're in an IB problem, you get stuck in the middle, make up a number and go with it. Keep carrying it through. If you want to look at how they mark points different ways, we'll talk about some of that later on. They have different uses, so if you show your work, they accept different answers. This is called the mark scheme. And if you notice in parentheses, like that's your exact answer, they accept the 3 sig fig answer. Okay, this is another example from a paper 2012 pyramid question. So it's going to build from simple to complex. It says M is the midpoint of BC. That's important to note. What else do we know is on the picture? That's on the picture. That's on the picture. So it says it's directly above. So we have a nice pyramid. So there's a right triangle here. So it says write down the length of OM. Well, OM is half the distance because it's right in the middle. So half of that, 115.2. They're going to lead you into what your next answer is. Find the length of VM. So now we have a right triangle. 115.2 squared plus 146.5 squared equals C squared. You can calculate that number. Find the area of triangle VBC. So VBC is this triangle right here. And so I just found the slant height, which if I draw that triangle out away from the 3D, I know the base is 230.4. And then what I just got for VM, the slant height, is the height right here. So my area of that triangle is 1/2 230.4 times what I got right there, which I did not calculate for you. And then it says find the volume of the pyramid. The volume of the pyramid is 1/3 the area of the base. This is a square pyramid times the height and not the slant height. So the area of the base is 230 by 230. Okay, so I went through it fast. I didn't do all the calculations. The last part says show that the angle between VM and the base of the pyramid is 52 degrees. So between VM, I'm going to erase some of that, and the base of the pyramid. So we're talking about that angle right there. Well, I found this 115.2. So I could use tangent, opposite over adjacent. I found this, I could use cosine. Either way, I'll use tangent because what's on there. So the tangent of that angle is 146.5 over 115.2. So I would do second tan. And I get 51.820. So to 2 sig figs, that's 52. So that's kind of a fast. If you go back and pause, make sure you understand. We will do more examples that have angles in class and kind of some unusual shapes as well.